Let's do another example of an inexact neutralization question, but this time the wording is a little bit different. Let's read this question. It says 0.15 grams of HCl is in 35 mils of water. This is mixed with 50 mils of 0.175 molar strontium hydroxide. What is the pH of the resulting mixture? So again, we have a strong acid and a strong base mixed together. There's two main differences in the way this question is set up. The first difference is that we're given grams of HCl instead of moles per liter. We're not given the concentration of the HCl before it's mixed. We're simply given the mass. That's okay because we can find moles from grams, and because we have the volume, we can also find concentration. So that will be one extra step that we need to do here. Then we have that it's mixed with a 50 ml solution of 0.15 molar strontium hydroxide. The other difference with this question is that the base has OH2 in it. So in other words, the strontium hydroxide, when it ionizes, is going to give us Sr2 plus 2 hydroxide ions. So for every 1 mole of base that ionizes, we're going to get 2 moles of hydroxide ion. When we calculate the concentration of OH minus in the resulting solution, we need to take this into account because we're going to have double the concentration for OH minus compared to the concentration of the base. So that's an important point, and if we don't do an example like this, you might find this difficult when you do a question in one of the assignments or the quiz. So let's go ahead and do this question just like we did the last neutralization question, but just keeping in mind what we've got here. We're going to have a few extra steps that we have to think about. So the first thing I like to do is think about when I'm mixing a strong acid and a strong base. Here is the net ionic equation. It's H plus OH minus giving us water. That's really what's happening in a neutralization reaction. Okay, we're forming water. And so this is helpful just to think about where we're going. So what we need to find out is what's the H plus concentration after dilution, okay, and what's the OH minus concentration after dilution. And once we know those two concentrations, we can compare them and see which one is in excess. And then we can figure out what is the pH of that solution. So we'll start with the acid. Okay, so we've got the HCl. Okay, let's think about this for a minute. The HCl is going to ionize to give us H plus Cl minus. Okay, now we don't have a concentration that we can just plug right in here and start off with the dilution calculation. So what we'll do instead is we're going to first find out what's the concentration of HCl originally. Okay, we're given grams and we're given the volume. So let's find out what is the concentration of HCl. Okay, at the start. So this is before dilution. Okay, and to do that, I'm going to need to know, remember that concentration is equal to moles divided by volume in liters. Moles per liter, that's concentration. So I need to figure out how many moles of HCl I have, and then I'm going to divide by the liters, which I'll have to change from mils to liters. So we can go ahead and do that. So let's first figure out what are the moles. Let's find N. Okay, so we have 0.15 grams of HCl, and I'm going to need to convert that into moles. Remember that to convert from grams to moles, we use the molar mass of the compound. So the molecular weight or the molar mass of HCl is equal to the mass of a hydrogen atom, which is 1 gram per mole, plus the mass of a chlorine atom, which is 35.5 grams per mole. So the molecular weight of HCl is 36.5 grams per mole. So every 1 mole of HCl has a mass of 36.5 grams. So I can put that conversion factor in. I'm going to put my 1 mole on the top, and my 36.5 grams goes on the bottom. And that's so that I can cancel out of grams and be left in moles. So moles of HCl is equal to 4 oopsie, sorry, 4.10958, so I'll say 6 times 10 to the negative 3. Okay, there's moles. Now I want to find the concentration. So the concentration is equal to moles divided by volume. Volume must be in liters. So I'm going to go ahead and put in my moles, 4.1096 times 10 to the negative 3 divided by volume. I'm going to use the original volume of 35 mils, so what I'm finding here is the concentration before the dilution. I'm just doing this to break it down a little bit into some nice easy steps. Okay, so we've got 35 mils, but I have to change that to liters, so I could just divide it by 1,000. Okay, so that's going to be 0.0, is it 35? Yeah, 123.035, and keep my sig figs. There should be one more 0 after that. Liters. Okay, so my concentration is equal to 1.17417, if I round up, okay, times 10 to the negative 1 moles per liter. So now I'm in units of moles per liter concentration. So there's my original concentration of the HCl. That usually is what is given to us in a question if it's a little simpler. Next, I have to figure out what is that concentration after dilution. So now let's do a dilution calc. Alright, so C2 is equal to C1 V1, or C initial V initial, divided by the final volume, or C2. And so the concentration of the HCl after dilution is going to be equal to this C1, so 1.17417 times 10 to the negative 1 moles per liter. Now we're going to multiply that by the initial volume. Here it doesn't matter if we're in milliliters because this is a dilution calculation and the units of volume are going to cancel. Okay, divided by the final volume. Coming back to my question, my final volume is 35 mils plus 50 mils. So that's 85 mils. And my units of volume cancel. Let's get rid of those. And my answer is going to come out to be equal to, okay, we have 4.8348. Well, again, I always want to leave some units here. I don't want to round too early. Times 10 to the negative 2 moles per liter after dilution. And I'm going to keep track of my sig figs, but I don't want to round. So here, if I go back to what I originally started with here, I had 1, 2, 3 sig figs, and so I'm going to go ahead and underline my 1, 2, 3 sig figs, but I won't round yet. Okay, now I'm ready to find the concentration of my hydroxide ion after dilution. Okay, so, and before I do that, actually, let me just go back for a second. The HCl concentration that I found after dilution is equal to the H plus concentration because it's in a 1-to-1 ratio. The acid and the H plus ion is in a 1-to-1 ratio. So this is also equal to my H plus concentration. Just to be clear. Okay, next we need to find the concentration of hydroxide after dilution. And we do the same process. It's a little easier this time because we don't have to deal with grams of the base. We have the concentration of the base. So again, we start by writing out our ionization reaction of the base. So it's strontium hydroxide, and it's going to ionize to give us strontium 2 plus cation plus 2 hydroxide anions. And again, we have that 1-to-2 ratio, which is going to be important to us at the end of this calculation. So to find the concentration of the strontium hydroxide after dilution, we need to do a dilution calculation. So it's going to be C1 V1 divided by V2. So we start with the initial concentration of the strontium hydroxide, which was 0.175 molars. V1 is 50 mils, and the final volume is 85 mils. So we can go ahead and plug this in. So C1 is 0.175 moles per liter times by the initial volume, which is 50 mils, and divided by the final volume, which was 85 mils. And again, it's okay to have mils here because this is a dilution calculation where there's a volume in the numerator and the denominator. So as long as my units of volume are the same, they're going to cancel. So I'm left with, my answer is going to come out to be equal to 1.02941 times 10 to the negative 1 moles per liter. Sorry about the messy writing, hard to write here with this mouse. Okay, and that's the concentration of my base after dilution. Okay, now remember that we said it's in a 1:2 ratio with the hydroxide. So the concentration of hydroxide ions is going to be 2 times this amount. Okay, so 2 times 1.02941 times 10 to the negative 1 moles per liter. And that's going to come out to be 2.0588. And that's a 5. Okay, times 10 to the negative 1 moles per liter. And it's important to keep track of my sig figs, but I don't want to round yet. So again, here was allowed to have 3 sig figs. So I'm going to go ahead and just underline those 3, but I don't want to round yet. That will introduce error. So now I have concentration of OH minus, concentration of H plus, and I'm ready to find out which one is in excess. So I've got H plus OH minus gives me water. And I've taken into account the 2 hydroxide ions that are produced by the base, and I've got a final value here so I can compare them. So I've got 2.0588 times 10 to the negative 1 moles per liter for my base, and for my H plus I had 4.8348 times 10 to the negative 2 8348 moles per liter, 3 sig figs. Okay, so I can see by just looking at them here that my base is in excess. It's the greater number. Here I've got an exponent of negative 2 compared to negative 1. So if you took those out of scientific notation, that might help you as well to see that the OH is in excess. So we've got more of the concentration of OH, and now we can find by how much. So concentration of hydroxide in excess is equal to however much OH I started with minus the concentration of the H plus, because an equal amount of that, equal amount of OH minus to the initial H plus that I have will be reacted, right? So all of the H plus gets reacted with an equal amount of OH minus, and then I'm left with some leftover. So I've got the OH minus at the start, or I should say here after dilution, minus the concentration of H plus that I'm starting with after dilution, and it's going to be equal to, we've got 2.0588 times 10 to the negative 1, keeping track of my sig figs, there's 3 there, minus 4.8348 times 10 to the negative 2, and keeping track of my 3 sig figs. This is important here now because I'm about to apply the subtraction addition rule, which means I'm going to have to round my answer to have 2 decimal places. And so my answer is going to come out to be equal to 1.57 if I leave some numbers and I haven't rounded yet, times 10 to the negative 1 moles per liter. Okay, and again, I don't ever want to round my any of my answers until the very, very end. So I'll just keep track of sig figs. So the decimal place rule here tells me that I'm allowed 2 decimal places. So that means that I'm allowed up to there. So there's a total of 3 sig figs in this answer, 2 decimal places. Okay. Now I can go ahead and find what is the POH and then what is the pH. So the POH is equal to the negative log of the OH minus concentration. So it's the negative log of this value, 1.5753 times 10 to the negative 1 moles per liter. So the negative log of this number comes out to be 0.8026. Okay, keeping track of those sig figs again. There was 3 here, so there's 3 there after the decimal place. Now that's a POH value, and I'm interested in the pH. So the pH is going to be equal to 14 minus the POH. So 14 minus 0.8026. And so the pH is equal to 13.197. And 3 sig figs after the decimal place here. Remember, for a pH and a POH value, we do not count any digits in front of the decimal place as being significant. Okay, so my 3 sig figs comes here at the end afterwards, and that's my final answer for the pH. So this is a basic solution with a pH of 13.197. Lots of calculations for one question that looks pretty simple, but it is fairly straightforward once you break it down and you figure out that you need to figure out the H plus concentration after dilution and the OH minus concentration. And then once you do that, you determine which is in excess and then the associated pH or POH value, depending on what you're being asked to find. You always want to pay attention to the question itself and see, what is it actually asking me? Okay, try some of these on your own as well to help really solidify this.